Hi, I'm Pete Jackson from Jackson 5 Medicine. By the end of this video, you should be able to understand the physiological control of blood volume and the glomerular effects of the renin angiotensin system. The control of blood volume is key in the longer-term maintenance of your blood pressure. Blood volume is mediated by the kidneys and is determined by the pressure of the blood going through the renal artery. One key thing to remember when looking at volume is that if in doubt, water follows sodium. So first, let's assume you have a drop in circulating volume for whatever reason, which in turn leads to a drop in blood pressure. There are two factors that come into play. Firstly, there is the drop in blood pressure itself, which will reduce blood flow into the kidneys. Secondly, there is the baroreceptor mechanism, which detects this drop in pressure and increases sympathetic tone. This in turn causes vasoconstriction of the renal artery, which will further impede blood flow into the kidneys. This drop in blood pressure is detected in the juxtaglomerular apparatus. This in turn releases renin into the bloodstream. Renin then cleaves a plasma protein called angiotensinogen into angiotensin 1. Angiotensin 1 is then converted to angiotensin 2 by angiotensin converting enzyme, or ACE, which is found on the surface of the pulmonary endothelium. Angiotensin 2 has a huge amount of physiological effects, but the key ones are as follows. Firstly, it is a potent vasoconstrictor, which helps increase blood pressure through an increase in systemic vascular resistance. This vasoconstriction is slightly different in the kidneys, which is something I'll come on to later in the video. Secondly, it stimulates the release of ADH, which causes aquaporin upregulation in the collecting duct, increasing water reabsorption. Thirdly, it causes a feeling of thirst. Fourthly, angiotensin 2 stimulates the sodium-hydrogen exchanges located on the cell surface of the proximal tubule and the thick ascending limb of the loop of Henle, in addition to sodium channels in the collecting duct. This will ultimately lead to an increase in sodium reabsorption, since water follows sodium will increase circulating volume. And lastly, it will stimulate the release of aldosterone from the adrenal cortex. Aldosterone in turn upregulates sodium-potassium pumps, therefore increasing sodium reabsorption in the distal convoluted tubule. And since this is a steroid hormone, this is done through nuclear stimulation of the endothelial cells. There are a number of regulatory mechanisms involved in this process as well. Firstly, an increase in volume will increase the blood pressure. This will decrease the release of renin, and therefore less water will be reabsorbed. But also, atrial stretching from volume overload will lead to the release of atrial natriuretic peptide, or ANP, which will act in an antagonistic way to angiotensin 2. I mentioned earlier that angiotensin acts slightly differently in the kidney. As we know, it will constrict the renal artery and also the efferent arteriole. However, it has a lesser effect on the afferent arteriole. To remember which way round this is, think of A before E. The afferent goes into the glomerulus and the efferent leaves it. This helps create a pressure in the glomerulus to maintain your glomerular filtration rate, remembering that narrowing of a lumen increases the pressure.